looking crazy, a storm on the horizon, the pressure is low. Gotta get moving, put on a show. The news is all buzzing, state of alert, but we've got a plan, we're ready to work. Emergency Management Associates, we're here for the crisis, we're here for the fates. From the first sign of trouble to the all clear sign, we're on the front lines, we're one of a kind. Emergency Management Associates, we're the calm in the chaos, we're opening gates, connecting the dots and making the calls. We're picking you up when you're starting to fall. See a little fire or a rising flood, we're a well-oiled machine, we're running in the mud. From the city hall meetings to the rescue teams, turning worst case scenarios into hopeful dreams. We're training the people, we're stocking the gear, we're the team you can count on when trouble is near. Emergency Management Associates, we're here for the crisis, we're here for the fates. From the first sign of trouble to the all clear sign, we're on the front lines, we're one of a kind. Emergency Management Associates, we're the calm in the chaos, we're opening gates, connecting the dots and making the calls. We're picking you up when you're starting to fall. It's more than a job, it's a calling, you see. Prepared for the present and what's yet to be. Every second counts, we're ready to react for our communities. We're making an impact.
Oh yeah.
Emergency Management Associates, we're here for the crisis, we're here for the fates. From the first sign of trouble to the all clear sign, we're on the front lines, we're one of a kind. Emergency Management Associates, we're the calm in the chaos, we're opening gates, connecting the dots and making the calls. We're picking you up when you're starting to fall. Yeah, we're picking you up, we're ready to go. EMA, let's get this show on the road.
Can we get this show on the road, guys? I think we shall. I hope we shall. This is Emergency Management Associates on the air for you today. We're coming to you from the Area Command, 392 miles west of Kitty Hawk Beach, North Carolina. How about that, guys? We're here and we're on the air. We want to welcome everybody to our program this morning, or this afternoon, should I say. It's a wonderful day in the neighborhood, so to speak. Wonderful day in the neighborhood, if you know where the neighborhood is. Let's talk about that. How about that? Let's do this thing. Now, guys, we've had some earthquakes, okay? We've had some earthquakes, a little bit of everywhere, okay? We're going to talk about earthquakes primarily in Japan and Southern California today. I've got a complete presentation that I've worked up for you. I hope you'd stay here the entire time we're on the air. Now, folks, also, please, okay? I'm asking you very nicely, please help us. Please help us. Just during the last few days, our car stopped working. Why, you might ask? Our alternator died on us. Our alternator that charges the battery died on us. We need a new alternator. Now, that could cost anywhere between $100 and $400. If you have it in your minds and you're able to help us, please do it. I put up our PayPal links here, scrolling across the bottom of your screens here. You can help us there as well, okay? Also, if you will, and you have the ideas with the next few weeks, please help us with keeping this channel on the air by contributing to our program here. You can do that through our mailing address, 504 Bethel Road, Box 401, Morganton, North Carolina, The zip code here is 28655. Also, if you want to add any comments, questions, or even have ideas for our program, please submit those to our email address, rltnspdema@gmail.com. rltnspdema@gmail.com. Let's get this show on the road, guys. We have a lot of things to talk about. First off, let's go to our USGS map and show you what happened this morning, early this morning, okay? This happened at approximately 9:15, 9:20 this morning Eastern Time, but it was actually at approximately 11:15, 11:20 p.m. Monday night in Japan, almost in the middle of the night in Japan. We're going to talk more about that in just a few minutes. This is what we're showing here on the USGS map. We're showing you the 7.6 earthquake right there, plain and simple, right in front of you. We're showing you that earthquake. Why? Because it's important. 7.0, 7.6 earthquakes are major earthquakes. Anything over 7.0 to 10.0 and beyond are major earthquakes. This was a 7.6 major earthquake, at least a 7.6 major earthquake. This may have been, and I'm going to say this right now, this may have been an 8.0 earthquake. This may have been as large as an 8.0 magnitude earthquake. Again, what you're seeing here on the USGS map is not contingent on what has actually happened. Okay? Again, the USGS is not showing all the earthquakes. Okay? Let me bring up my device here and I'll show you what the European agency has to show us here. Okay? Give me just a second here. All right. I'm going to show you exactly what the European agency is showing us. The USGS is showing us basically 4 aftershocks, only 4 aftershocks. Look at what the Europeans are telling us. That's a lot more aftershocks. A lot more aftershocks. Let's go here and talk about this. This is a 7.6 earthquake. That is a 7.6 earthquake. This occurred at 9:15 Eastern Time, our time here in the United States. It was at 11:15 p.m. Monday night in Japan. I'm going to show you the large earthquake aftershocks here. Further offshore, 59 miles east-northeast of Hachino, Japan. I'm going to refer to Hachino, Japan in just a minute on a video I'm going to show you. This is a 5.5 earthquake here. That's a 5.5 earthquake right there. USGS not showing us that. Further out here to the east, 2 more earthquakes here. Further out to the northeast, this is off the coast, south of Honshu, Japan, off of Hokkaido. This is a 5.0 large earthquake right there. 5.0 large earthquake right there. There's another large earthquake just north there. This is a 5.8 large earthquake, aftershock. All of these earthquakes are aftershocks. Further to the southeast here, this is east coast of Aomori, Prefecture, Japan. This is a 5.2 earthquake. 5.2 earthquake. North there, a moderate 4.3. Okay? The earth is still shaking there. This is a 4.1 earthquake here. 4.1 there. Up to the northwest, this is a 4.4 earthquake here. Okay? Down south, this is a 3.9 earthquake here. A small 3.9, 4.0. 3.9 small, 4.0 moderate quake here. Okay? Then over next to the 7.6, this is a 3.6 aftershock, a small 3.6 aftershock. The other earthquakes here offshore, other than the 7.6, other earthquakes offshore probably were not even felt on land. Now I'm going to go over to a report made by CNN this morning. Okay, most of you know that I don't like CNN at all. I don't usually watch it, but this was available to us. I'm going to show it to you right now. Let's look at that video. Wolf Blitzer is the main actor here. He's going to go to his report in Japan.
Japan captures the moments. A very powerful earthquake slammed the country this morning, and you can see the lamps in this person's home swinging wildly. Because of the earthquake, parts of Japan's coast are now under what's called tsunami warnings. CNN's Hanako Montgomery is following this very closely from Tokyo right now. So what's the latest right now? What's happening?
Yeah, well, if the Japanese government has issued that tsunami warning, as you mentioned, which means that parts of Japan, especially northern Japan, which was very close to the epicenter, could see waves of up to 3 meters hitting its coast. So the Japanese government so far has warned residents, especially those living near the coastlines, to evacuate, to get to higher ground, and to await for any further information. And Wolf, I do want to just point out here that this earthquake was very, very powerful. It measured 7.6 in magnitude. And I live in Tokyo, and even I felt it. I was actually just getting ready for bed. I was in my pajamas when this earthquake hit, and my entire apartment began to shake. So you can just imagine how powerful and how frightening this earthquake was for residents who live in the northern parts of the country. Now, the Japanese Prime Minister has said that the Japanese government is responding to this disaster. They will be putting their full efforts behind this and will be conducting any search and rescue missions if any are needed. They'll also assess any potential damage from this earthquake and the subsequent tsunamis. But so far, Wolf, even though a tsunami warning has been issued where we could see waves of up to 3 meters hitting Japan's coast, so far the tsunami waves haven't been that high yet, some measuring less than a meter, about half a meter. So again, these are updates that we will be monitoring in the coming minutes and hours as Japan continues to respond to this natural disaster. Wolf.
Okay, that's a report directly from Japan.
From one hotel room?
That's a report directly from Japan, guys, right after the earthquake hit. But we're not done yet, okay? She talked about tsunami warnings. This morning, they had issued 2 tsunami warnings within 45 minutes that we were on the air. They issued 2. Right now, we're on the 5th tsunami warning. Let me read that to you right now, okay? Tsunami message number 5. This message is issued for information only in support of the UNESCO Pacific Tsunami Warning and Mitigation System. This is meant for national authorities in each country of that system. The tsunami forecast is updated in this message. Again, a preliminary magnitude of 7.6 earthquake had hit, okay? That hit at approximately 14:15 UTC, which was 11:15 Japan time last night, or tonight, I should say, Monday night, okay? The tsunami threat has largely passed. Government agencies responsible for any impacted coastal areas should monitor conditions at the coast to determine if and when it is safe to resume normal activities. Persons located near impacted coastal areas should stay alert for information following instructions from local authorities. Remain observant and exercise normal caution near the sea. Minor sea level fluctuations up to 0.3 meters and above. Minor sea level fluctuations of 0.3 meters and above, that's 3 inches high, and below the normal tide level may continue over the next few weeks. Okay, I'm going to say hours. Minor sea level fluctuations of 0.3 meters, 3 inches above and below the normal tide may continue over the next few hours, weeks. The following are tsunami wave observations from coastal and/or deep ocean sea level gauges at the indicated locations. The maximum tsunami height is measured with respect to the normal tide level. The gauge location, I don't know exactly where these gauge locations are, but they have 3 gauge locations. One at 44.8 north latitude, 140.7 east longitude. Wave period, 26 minutes. Timer measurement at 16:36, 4:36 p.m. Maximum tsunami height, 0.19 meters. That's 19 inches high. At 39.0 north and 141.8 east. At 15:12 hours, 3:12 p.m., 0.16 meters high. That's 0.5 feet. Okay, that's 6 inches high, basically. 6 inches high. The wave period was 10 minutes. Near Koshino, Japan, 43.0 north to 144.4 east. Time of measurement, 15:20 hours, 3:20 p.m. Maximum tsunami height was 0.1 meters, 0.4 feet. Okay, 0.4 feet, that's 4 inches high. They don't have a wave period measurement. Meaning in term of minutes. The Japanese Meteorological Agency has reported a wave amplitude of 0.7 meters high, 0.77 inches high at the Kuchiko tide gauge. The next update, this will be the final update issued for this event, unless new information is received or the situation changes. Authoritative information about the earthquake from the U.S. Geological Survey can be found on the internet at USGS.gov. Further information about this event may be found at www.tsunami.gov. Coastal regions of Hawaii, American Samoa, Guam, and CNMI should refer to Pacific Tsunami Warning Center messages specifically for those places that can be found on www.tsunami.gov. Coastal regions of California, Oregon, Washington, British Columbia, and Alaska should only refer to U.S. Tsunami Warning Center's messages that can also be found at tsunami.gov. Those messages have stopped. Those messages have now stopped. There is no further message at all. Okay? The last tsunami message was message number 4, coming for British Columbia, the United States area. Let me read that to you. Okay? Tsunami message number 4. The message is issued for information only in support of UNESCO Pacific Tsunami Warning and Mitigation System. The tsunami forecast is unchanged in this message. Again, the magnitude was a 7.6 major earthquake off the coast of Japan. Tsunami waves have been observed. Based on all available data, hazardous tsunami waves are forecast for some coasts. Tsunami waves below 0.3 to 1 meters above tide level. 0.3, which is 3 inches to 1 meter, 3 feet above tide level, that are possible around the coast of Japan. The coast of Japan. Okay? Estimated times of arrival, they have the times of arrival for the Japanese locations. I read that to you just a minute ago. There is no tsunami alert on the west coast of North America. I'm going to repeat that. There is no tsunami alert on the west coast of North America at all. Okay? That's it. That's all. I gave you most of this information this morning. At the time, there was no data for the United States or Canada. None at all. But that's all we have. That's all we have, guys. Now, I showed you, or I told you about the report from CNN. They gave that. It was a great report because the woman reporter was in Tokyo, Japan. She talked about it. They showed the chandelier light swinging from the ceiling. That's tremendous swinging. That happens when you have a major earthquake like they had there all the time. I've seen it in other parts of the world. They've had this many times before. This is nothing new. Now, I want to tell you this. Japan also told residents to evacuate as powerful earthquakes struck northeastern Japan. 90,000 people advised to take shelter after a 7.6 magnitude hit, and only 20 injuries were reported. Okay? 20 people were injured. That earthquake triggered the tsunami warning center, and it was not activated necessarily. They only had minor sea level fluctuations. Earthquake and tsunami warnings prompted orders of 90,000 residents to evacuate, although the warnings were later downgraded to advisories. Tsunami warnings were issued for the prefectures of Hokkaido, Aomori, Iwate, and tsunamis from 20 to 70 centimeters, 7 to 27 inches high, 7 to 27 inches high, 20 to 70 centimeters high, were observed at several ports. A tsunami 70 centimeters was measured in Kuji Port in Iwate Prefecture, just south of Aomori, and tsunami levels up to 50 centimeters struck other coastal communities in the region. The Fire and Disaster Management Agency said 23 people were injured, including one seriously. Most of the victims were hit by fallen objects. Public broadcaster NHK reported, adding that several people were injured in a hotel in Hachoi, and a man in Tohoku was slightly injured when his car fell into a hole. Satoshi Kato, a vice principal of the high school in Hochio, told the public broadcaster NHK that he was home when the quake struck. The glasses and bowls fell and smashed into shards on the floor. Kato said he drove to the school because it was a designated evacuation center. And on the way, he encountered traffic jams and car accidents as panicked people tried to flee. Nobody has yet to come to the school to take shelter, he said. About 480 residents were taking shelter at the Hochia Air Base, and 18 defense helicopters were mobilized for a management damage assessment. About 200 passengers were stranded for the night at Nuchitose, Chitose Airport in Hokkaido. The epicenter of the quake was 50 miles, 80 kilometers off the coast of Aomori Prefecture at a depth of 30 miles deep. On Japan's 1 to 7 scale of seismic intensity. The trembler registered on an upper 6 in the Aomori Prefecture, a quake strong enough to make it impossible to keep standing or to move without crawling. In such tremors, most heavy furniture can collapse, wall tiles and window panes are damaged in many buildings. Okay? Now, that's why we are now asking everybody, if you feel an earthquake, hold on. A 6.2 earthquake just hit off Japan. It's another aftershock A 6.2 aftershock hit off of Japan just moments ago. Okay? The East Japanese Railway suspended some services in the area, which was also hit by a massive 9.0 magnitude quake in March 2011. Okay? Again, the East Japanese Railway system suspended services in the area. This railway was also hit by a massive 9.0 magnitude earthquake in March 2011. We already know about that. No irregularities were reported at nuclear power plants in the region by Tohoku Electric Power and Hokkaido Electric Power. Another 6.1 earthquake just happened aftershock off the coast of Japan just a moment ago. 6.1 aftershock again. These aftershocks are going to continue for some time. Okay? Now, Tohoku Electric did say, however, that thousands were without power. Japan is the world's most earthquake-prone country, with a tremor occurring at least every 5 minutes. A tremor on Japan occurring every 5 minutes. Located in the Ring of Fire, in the arc of volcanoes and oceanic trenches. The Ring of Fire is encircling the Pacific Basin. Japan accounts for about 20% of the world's earthquakes of magnitude 6.0 or greater. Again, listen to my words. Japan accounts for about 20% of the world's earthquakes of magnitude 6.0 or larger. Okay? Now, I'm going to continue this for a minute. Then we'll get into California earthquakes in just a second. And I will show you the Japanese earthquake showing up in California. After checking earthquake data from 2000 till present, I noticed a marked decrease in the number of earthquakes in 2018. 2018. That's an important date. Think about this. Remember that date. A marked decrease in earthquake activity in 2018. The number of recorded earthquakes globally didn't necessarily decrease in 2018. Rather, there was a predicted decrease in very large magnitude 7 earthquakes or larger. Okay? There was a predicted decrease in very large, very major 7.0 plus earthquakes. Okay? Those major earthquakes slowed down. Now, this is while detection technology increased. The count of smaller quakes increased. That created confusion. Some data suggests fewer major earthquakes in 2018 compared to around 15. Usually they had 20 to 30 expected. But again, in 2018, there were only 15 major earthquakes happened, 7.0 larger. Okay? Possibly due to timing or plate creep. Tectonic plate creep here. But overall, seismic activity is always fluctuating naturally. Okay? Now, the Earth's rotation is slow over billions of years, primarily the 6.5 was just upgraded. Or excuse me, the 6.2 earthquake was upgraded to 6.5 just moments ago. The 6.2 earthquake that I told you about, the aftershock, was upgraded to 6.5. Okay? Getting back to what I'm talking about. Earth's rotation has slowed over billions of years. That's primarily due to the gravitational pull of the moon. Think about it. The gravitation of the moon affecting the Earth's rotation speed. Okay? It's a process called tidal braking or tidal friction. More recently, the polar ice caps been melting off and on due to what they say climate change. There is no such thing as climate change. Okay? But those melting polar ice caps during the summer cause additional measurable slowdown. During the summer, the melting polar ice caps cause an additional measurable slowdown. Okay? Primary cause, tidal breaking. The main long-term cause of Earth's slowdown is the gravitational interaction with the moon. Tidal bulges. The moon's gravity creates tidal bulges in the Earth's oceans and even at its surface, the solid surface of the Earth. This is around the equator of the Earth. Friction. As the Earth rotates, it pushes these tidal bulges ahead of the moon's position. Okay? As the Earth rotates on its axis, pushes these bulges ahead of the moon's position. The gravitational pull from the moon acts as a brake on these moving bulges, creating friction, particularly as ocean water drags across the seafloor and the continents. Let's talk about energy transfer along with this. This friction dissipates the Earth's rotational energy as heat. The friction dissipates Earth's rotational energy as heat, slowing the planet's spin. The last rotational momentum is transferred to the moon. Earth's rotational momentum is transferred to the moon, causing it to gradually move into a slightly higher orbit around the Earth, increasing the length of the day by minuscule minutes, 2.3 milliseconds per century on average. A slowing Earth rotation caused the equator slightly shrink. A slowing Earth rotation is causing the equator to slowly shrink, squeezing tectonic plates. We talked a lot about the tectonic plate movement, guys, but the slowing Earth's rotation has caused the equator to slightly shrink, squeezing the tectonic plates, adding stress to the fault lines as well, and potentially triggering more major earthquakes. 7.0 and larger. Okay? Now, these situations fluctuate every 5 years. In other words, the moon grabs the Earth and squeezes the Earth. Okay? The gravitational pull squeezes the equator of the Earth, which causes plate tectonics to move, triggering major earthquakes. But the slowdown of the major earthquakes happens every 5 years. Remember that. The slowdown precedes periods of heightened seismic activity. Again, every 5 years. This is a hypothesis, not a definitive predictor. The Earth's rotation isn't perfectly constant, as we know. It slows down and speeds up by tiny amounts due to mass shifts. Ocean currents, the mantle changes, or even large earthquakes. When the Earth slows, its equatorial bulge slightly shrinks, like a spinning skater pulling their arms in. Okay? Now, tectonic plates, however, don't shrink as easily at their surface. This difference in response puts added stress on plate boundaries. This extra squeezing acts like a trigger on fault lines already under stress, making large earthquakes more likely. That extra squeezing acts as a trigger on the fault lines. They're already under stress, such as an example as the San Andreas Fault or the Cascadia subduction zone. Okay? Scientists have observed that periods of slowing rotation lasting about 5 years have historically been followed by an increase in magnitude 7+ earthquakes, with an uptick occurring about every 5 to 6 years as the slowdown began. The study suggested that the slowdown starting around 2011 meant a period of increased seismicity was due to follow, potentially leading to more large earthquakes every year. Every year. If the hypothesis holds, this being 2025, the fourth year of seismic slowdown, starting in 2027, we should be seeing an increase in seismic activity. Let me repeat that. If this hypothesis holds, this being 2025, and we're at the end of 2025, the fourth year of seismic slowdown, starting in 2026 to 2027, we should be seeing an increase in seismic activity according to the graph that they put together. Okay, this link is a strong correlation and a hypothesis, not a proven cause and effect. And scientists are still working to understand the precise mechanisms. The correlation offers a warning of increased potential. This correlation we've been talking about now offers a warning of increased potential for large earthquakes, but it doesn't predict when, where, or how big specific earthquakes will be. Okay? It only offers us a warning of increased potential. There is a hypothesized correlation between the long-term slowing of the Earth's rotation speed and an increase in the number of major earthquakes, magnitude 7.0 and larger. Okay? The correlation between the long-term slowing of the Earth's rotation speed and an increase in the number of major earthquakes. But this is a complex scientific topic with ongoing research and some skepticism. Now, some researchers, notably geophysicists Roger Bilham and Rebecca Bendick, have observed a statistical correlation over the past century, 100 years, where periods of slight deceleration in the Earth's rotation were followed by an uptick in the annual number of major earthquakes, about 5 to 6 years. However, a definitive causal link has not been fully established, still a subject of scientific debate. Okay, now let's talk about proposed mechanism here. The leading theory suggests that the Earth's spin slows slightly. The equator subtly shrinks. Okay, the leading theory suggests that the Earth's rotation slows slightly when the equator shrinks. The tectonic plates do not shrink as easily, which, as I said before, puts added stress on already strained plate boundaries, potentially triggering large earthquakes that are poised to hit anyway. Okay, putting already added stress on plate boundaries, potentially triggering earthquakes that were already posed to hit anyway. That means those triggered earthquakes will hit. The changes in Earth's rotation speed are minuscule, amounting to just milliseconds per day. But there's also cause factors like atmospheric wind, ocean currents, and the motion of the plate's molten core. There is statistical evidence here. During periods of high seismicity, like we've seen lately, the annual number of magnitude 7 plus or greater earthquakes globally has been observed to increase from an average of 15 to 20 to 30 earthquakes a year. Okay? The annual number of magnitude 7 or greater earthquakes globally has been observed to increase from an average of 15 per year to 20 to 30 per year. Think about it. We just got through having a 7.6 earthquake off of Japan. 2.5 months ago, we had another 7.8, they had a 7.8, and then an 8.8 that was actually a 9.4 earthquake. Unreal. That was off the southeast coast of Kamchatka Peninsula, Russia. Okay? What did we just got through having this past weekend on Saturday? Who was that? A 7.2 earthquake in Alaska. A 7.2 earthquake over in southeastern Alaska. While the exact location and timing of a specific earthquake cannot be predicted, understanding this long-term pattern could help us forecast periods of generally increased global seismic risk, potentially encouraging authorities in high-risk areas to accelerate earthquake preparedness and building retrofitting efforts. Building retrofitting efforts in high seismic areas such as Los Angeles, San Francisco, British Columbia, Canada, Washington State, Oregon State, and other places around this planet. It is important to note that earthquakes themselves can cause a minuscule change in the planet's rotation speed. Earthquakes can cause a minuscule change in the planet's rotational speed and the axis position due to the redistribution of the planet's mass. The redistribution of the planet's mass, meaning the tectonic plate redistribution after an earthquake hits, like we just saw today, and also the ocean waters moving. Yes, this earthquake caused ocean waters to move. Okay? Again, it's like an effect of a figure skating pulling in a rotational speed, and then they spin faster when their arms are together like this. Now, all this has led to ask the following questions. What is the typical magnitude of earthquakes associated with changes in Earth's rotation? What is the typical magnitude of earthquakes associated with Earth's rotation? The association between the Earth's rotation changes and earthquakes are primarily linked to an increase in the number of earthquakes of magnitude 7.0 and larger. Okay? Earth's rotation speed is linked to an increase in the number of magnitude 7.0 earthquakes and larger. What is the magnitude range? The statistical coordination observed by those researchers that I talked about, Roger Billum and Rebecca Bendick, specifically focused on major earthquakes, defined as those with magnitude 7.0 and larger. Increased frequency. During periods of Earth's rotation deceleration that we've seen between 2021 and 2025, the number of 7.0 plus earthquakes increases from a long-term average of 15 to 20 per year to about 25 to 30 per year. What is the potential for magnitude 6 plus? While the primary correlation is with 7.0 plus earthquakes, due to more complete historical data, some research suggests that the relationship also persists for damaging 6.0 plus earthquakes. Okay? 6.0 earthquakes can also cause major damage. And they can also cause the slowing of their spin, the rotation. Smaller magnitude earthquakes below 6.0 do not show the same clear correlation with these long-term rotational fluctuations of 6.0 and 7.0 respectively and above. Now, their theory suggests that there is subtle global stresses that are enough to trigger only those major events that are already poised to rupture. The 6.0 to 7.6 or 7.0 plus earthquakes already posed to rupture are going to hit. They're going to hit. They're going to hit on highly stressed plate boundaries, such as the one we just saw in Japan, and prior to that over in Alaska, and prior to that over off the Kamchatka Peninsula, the plate boundaries. With all that said, What about the causation with the Cascadia subduction zone and the northern and southern California San Andreas Fault? All bets are off. Both faults are already highly charged. Seismic energy on the fault has already been posed to wreak havoc on that region at any time. Both faults are highly reactive, already highly charged. Seismic energy at the Cascadia and the San Andreas Fault are already poised to wreak havoc on that region at any one time. With the plates already poised to move in a huge fashion, Cascadia is literally a give me at this point in time. It's a give me at this point in time, meaning it could go at any point. When Cascadia does go, it is thought we just got through having another large 5.1 earthquake off of Hokkaido just a minute ago. When Cascadia earthquake goes, it is thought that the San Andreas will be triggered. Seismic energies already hold up off the Pacific Northwest, off of Washington and Vancouver Island. Okay? We showed you this before. Let's bring up the USGS map again so I can show you what's actually going on. Okay? Let me take down our EMA banner. Let's go over to the USGS earthquake map. You can already see on the map here that there are earthquakes continuing to hit. Okay? This is the 5.1 that just hit. Again, the USGS is not showing all the earthquakes here. They never do. Okay? Let's move over to the east here. Let's move over to the east. The Cascadia subduction zone right here, off the coast of Vancouver Island, and Washington State. This is the location where they believe the Cascadia earthquake will occur. Between the Cascadia subduction zone to the east and the Juan de Fuca plate to the west. The Juan de Fuca plate you see here is a zigzag fault. This is where the Cascadia 9.0, 10.0 earthquake is supposed to hit. The seismic energy, whether it's on either one of these faults, is going to head south. It's also going to head north. It's going to head north up here to Haida Gwaii, shaking Haida Gwaii tremendously. 9.0 energy up in Haida Gwaii. As it goes north, the energy is going to dissipate some as it moves north through this fault zone, going up here into the Gulf of Alaska. But this earthquake is going to majorly hit Alaska, possibly as high as a 7.0 to an 8.0 earthquake when it hits Alaska. Okay, it's going to move up the fault zone, hit Alaska here. We already see what has happened on Saturday here in Alaska. We've already had close to 400 earthquakes here in southeastern Alaska since Saturday. Again, the USGS is not even showing all the earthquakes here. Okay? But again, the Cascadia megathrust earthquake is going to hit in this region off the coast of Vancouver Island, British Columbia, Canada, and Washington State. The seismic energy can travel down the Juan de Fuca plate, down to the subsequent boundary over here that shows to be the Blanco fracture zone. This perpendicular line that goes from the Pacific Northwest down the Pacific Southwest. The Blanco fracture zone right there. From the Blanco fracture zone, it triggers down the Gorda Ridge. Okay? Then it goes down to the Gorda Escarpment going east and west way from the California coastline. Then it meets at the triple junction here of the Cascadia, the Gorda Escarpment, and the San Andreas Fault right here. The same thing goes. The same thing goes with if that 9.0, 10.0 Cascadia earthquake hits off the coast of Vancouver Island and Washington State here on the Cascadia subduction zone. That 9.0, 10.0 energy will be irradiated all the way down the fault zone. It will be echoed all the way down the fault zone down here. All the way down here to the triple junction here. That will trigger the San Andreas Fault. Chris Goldfinger in 2019, December 2019, he addressed an assembly, a forum of seismologists in San Francisco, December 23rd, 2019. He said at that time that the Cascadia earthquake could trigger the San Andreas Fault here. At that point in time, the subsequent energy of the Cascadia earthquake is going to trigger all the way down the San Andreas Fault. The San Andreas Fault follows the coastline of Northern California here. Then over here near Point Arenas here, it starts to go inland. Then it goes out over the coastline just before Northern California, just before the San Francisco Bay. It goes just west of San Francisco Bay, proceeds south. San Francisco Bay would probably feel an 8.0 earthquake. San Francisco Bay would feel an 8.0 earthquake all the way down the fault. All the way down the fault. Right here inland, we just barely had another earthquake here. This is a 2.6 earthquake here. This is a 2.6 earthquake. You can already see we've had a cache of earthquakes happen here in San Ramon today. San Ramon, folks, is on the Hayward Fault. On the Hayward Fault. Guys, we saw a 4.5 earthquake here in San Ramon about a month ago. Since then, the earthquake energy here has subsided and increased here, as you can see here. This earthquake that just happened here in San Ramon was a 2.6 earthquake, but it's not the only one that hit right just a few minutes ago. We've also got a 2.9, 3.0 right here. 2.9, 3.0 earthquake here. Look at all these earthquakes here. Okay, that earthquake in blue is a 2.9, 3.0, meaning a small earthquake. This earthquake here is a 3.6 small quake. 3.6 small earthquake. Let's go east for a minute. This is a 2.6. San Ramon, California again. Going south. This is a 1.6. Right next to a 2.2. Going south here, a 2.5. South again, a 2.1. Right next to it down here, this is a 2.1 here. Going all the way down to the south, this is also 2.2. So the largest earthquake today here in San Ramon is a 3.6 small quake. 3.6 small quake. The earth is moving here in the San Francisco Bay area, just east of the San Francisco Bay, on the Hayward Fault in San Ramon, California. One of our own EMA family members, Rob 52, his daughter lives here in San Ramon, and she obviously felt at least 2 of these earthquakes today. The small earthquakes can be felt. 3.0 large earthquakes can be felt. The 2s and 1, the 2.0, 2.9 are minor earthquakes that usually can't be felt except by maybe very, very sensitive people. Tremors 1.0 to 1.9 cannot be felt by anyone. Those are just tremors. Earth movement, earth shaking. but 3.0 and larger can be felt. And those earthquakes were felt by Rob's daughter here in San Ramon, California. Okay? It happened. It's continuing to happen, guys. This is continuing to happen. And actually, this was not on the Hayward. This was on the, what's it called? The, oh, now my mind's gone. Oh, man. I'm sorry, my mind just took off and left me. Anyway, there's two fault zones here. The Hayward is over here next to the San Francisco Bay. And over here, the other fault zone is also a very dangerous fault zone. This is building up with energy here. As these fault zones converge down here to the south, it becomes even more dangerous. The Hayward and this other fault come together as well as the San Andreas, right down here to the south, just east of Monterey Bay. Just east of Monterey Bay. All three of these faults coming together like this makes this area one of the most dangerous earthquake zones in the world. Makes it one of the most dangerous earthquake zones in the world. When the San Andreas fault hits, the energy from the Cascadia earthquake is going to come down the San Andreas fault here into San Francisco, probably as an 8.0 earthquake. This area is going to be completely devastated. Back in 1989, we saw a 6.9 earthquake that they now say was actually a 7.1 earthquake, maybe larger. Hit the San Francisco Bay, and it knocked down portions of the Bay Bridge. Caused fires, ruptured gas mains, ruptured water mains in the area. Caused billions of dollars in damage. It can happen again. That was in October 2019, or October 1989, sorry. October 1989. It can happen again, and it will happen. It will happen. As we go south, the San Andreas fault continues more inland. Okay, right here. This is the Pinnacles. We have oil and gas drilling going on here, and as a result, we have a 1.1 tremor here. Further south, off the San Andreas fault to the east, this is a 2.0 near Kettleman City. Kettleman City. To see this earthquake today in Kettleman City means this area is moving again. Almost all seismic activity around Kettleman City ceased about the beginning of last year. It's increased again, as you can see. Earthquake here, 2.7 magnitude earthquake, minor earthquake, 8 miles east-northeast of Kettleman City, California. Over here to the west, Templeton, California. This is on the Oceana Fault. The Oceana Fault here. 2.0 minor earthquake and a 1.5 tremor. Templeton, California. Further to the south here, you see another earthquake east of the San Andreas. Buttonwillow, California. Buttonwillow, California, 1.2 tremor. Notice I'm going south here. As the San Andreas fault goes south, that Cascadia energy that occurred up in Washington, Oregon will be somewhat dissipated. By the time it reaches this area, Los Angeles could actually see a 7.5 to 8.0 earthquake when this Cascadia energy reaches Los Angeles. Santa Barbara, Los Angeles area could see a 7.5 to 8.0 earthquake hit here as the seismic energy travels south. Today, just west of the San Andreas Fault on the San Jacinto Fault, Redlands, California, a 2.0 earthquake. 2.0 earthquake near Redlands, California. Over here to the west, Yorba Linda, where our former President Richard Nixon was born. Yorba Linda, California, here in Los Angeles, 1.0 tremor here. Notice this. They are hardly reporting any earthquakes here in the greater Los Angeles area. I'm going to throw that all to the wind. The information I'm about to show you in Los Angeles is going to prove by all data that the USGS is blown away here. They are not showing all the earthquakes here in Southern California. I'm going to show you an awful lot of activity here in Los Angeles area in just a few minutes. Going south here on the San Jacinto Fault. This is a 0.7 near Idlewild, California. Also right here, this is a 1.1 tremor, Idlewild, California, San Bernardino Mountains. The San Andreas Fault from Redlands south shows almost nothing. Almost nothing. What a joke that is. There is plenty of seismic energy here, and I can prove it. I've got the data to prove it. On the San Jacinto Fault going south, Ann's Gap. This is now in northeast San Diego County. 1.2 tremor here. Up here to the north, 0.4 microquake. This is a 0.7 microquake. This is 0.9, northeast San Diego County, the Anza Borrego Desert State Park. This is Borrego Springs, also part of the Anza Borrego Desert State Park here in northeastern San Diego County. Then we go further south here. Julian, on the San Jacinto. This is a 0.91.0 tremor here. 0.91.0 tremor here in Julian, California. Earlier this year, we had a 5.1 here in Julian, almost in the exact location here. Earlier this year. Further south, Ocotillo Wells. This is 14 miles northwest of Ocotillo Wells. This is in the Chocolate Mountains, in the Cuyamaca Mountains. Cuyamaca Mountains here. Now, let's go further south here. This is northwest of Ocotillo. This is actually southwest of Ocotillo, in the Imperial Valley. This is a 1.0 tremor. We go up here north, closer to the Salton Sea, on the western side of the Salton Sea here. This is a 0.7 microquake. This is southwest of Salton City here. Salton City is up here. This earthquake down here is southwest of Salton City. Now you see an earthquake here in the southern side of the Salton Sea. This is important. This is very important. This is a 1.8 tremor here. 1.8 tremor. What also is here? What also is here, guys? What also is here? The Salton Butte volcanoes here. The Salton Butte volcanoes here. Underwater here, under the Salton Sea. 1.8 tremor here near the Salton Butte volcano. Now, they're still not showing us earthquakes over here near Bombay Beach. I'm going to show you data here at Bombay Beach in a minute. Bombay Beach had some earthquakes here. They've had quite a few earthquakes here. 3.0 large earthquakes here at Bombay Beach already today. They usually do every day here. They have about 10 3.0 large earthquakes every day without fail. We go further south here. Here's a town called Calipatria. Calipatria. Remember this town. Up here, Bombay Beach. What do we have? We have the San Andreas Fault going down the eastern side of Salton Sea. At this point of Bombay Beach, the San Andreas Fault goes underneath the Salton Sea. It comes out here just south of Salton Sea here near Calipatria. There is a seismograph here in Calipatria. I'm going to show you readings from the seismograph here. Typically on any given day, there are anywhere from 75 to 150 earthquakes here at Calipatria every day. Every day. Okay? Let's go over here. At Calipatria, guys, the San Andreas Fault takes a southwesterly turn. Comes down here to Westmoreland, California. Up until 3 months ago, they had a seismograph that was active here in Westmoreland. They since shut it down. Now, occasionally, guys, we will get readings here on the USGS map from Westmoreland, but not often. Because I believe what they've done is they shut the Westmoreland seismograph off to the public. It's probably still operational, but they shut off to the public. We don't have any data from Westmoreland at all during the last 90 days. I don't think it's going to come back up either. They withhold that all the time, and I've talked about this before. Okay? But this is where the San Andreas Fault goes south. Takes a southerly turn here. Goes down here to Brawley. There's no seismograph here in Brawley. However, over here to the west there is. Imperial Valley. The town of Imperial here in the Imperial Valley. Right down here. I'm going to show you a seismogram here from the town of Imperial, showing earthquake data. Okay? Then we go south. There's also a seismograph located here in El Centro, California. I'm going to show you a ton of activity here in El Centro. 3.0, 3.3, 3.5 small earthquakes all over El Centro all day long. All day long here in El Centro. The San Andreas Fault. The San Andreas Fault down here in the Imperial Valley. Let's go south. Let's go over here to Holtville, California, right here. Holtville, California has a place here in Holtville that is located here as a museum. It's called the Salton Sea Desert Research Station here in Holtville. Holtville, California. Go figure. We have data here from Holtville showing a lot of seismic activity in Holtville as a result of activity from the San Andreas Fault. Every day it happens. Every day. You can find this data every day on the seismographs. Okay? This is very important. Very important. Now, I showed you these locations for a reason. When I show you the seismograms, I want you to think of these locations. It's important. Understanding what the seismology does, what the San Andreas Fault does, is very important what we're talking about here. The San Andreas Fault is moving. And it's moving in a great way. Moving in a huge way. We need to understand what's happening. My buddy Demon Catman, which is a moderator on this program, says Bombay Beach is on the Salton Sea, which looks like a footprint that would be where you get a bunion. Yes, you're right. You're absolutely right. The Salton Sea at the bottom of it looks like the toes of a foot. Right. Okay? The Salton Sea is an inland sea here in the Imperial Valley. Now, I'm going to take this USGS map down for a few minutes. I've shown you the major earthquakes that have been happening. I now want to show you the activity on the San Andreas Fault. I want to show you activity in the greater Los Angeles area and going south into the Imperial Valley and also San Diego County, Southern California. Cotton picking Southern California. This is important. I want everybody to understand what's going on here. The San Andreas Fault is active. The Cascadia subduction zone is active. Both seismic zones are perilled. Both seismic zones are already at the point where they're ready to rupture. Now, I want to also tell you this. When the San Andreas Fault goes, it's going to rupture all up and down the fault line. You're going to see earthquakes up and down the fault line when the San Andreas Fault goes. When the Cascadia goes, when the Cascadia earthquake hits, let me take this back down for a minute. When the Cascadia earthquake hits, the seismic energy is going to be felt up and down the entire coastline. Up and down the entire coastline from up here, British Columbia, Canada, Vancouver Island area, all the way down the coast of Washington, all the way down the coastline of Oregon, all the way down the coastline of California, all the way down to northern Mexico. But it doesn't stop there. Heaven forbid it doesn't stop there. This is going to be such a large earthquake. This is going to be such a large earthquake, a 9.0, 10.0 earthquake. It's going to be echoed across the entire North American continent. It's going to echo across the entire North American continent. Canada and the United States, all the way across to the East Coast. All the way across the East Coast. As the seismic energy dissipates across land, you're going to see a dissipation or the minor bleed off of the energy. For example, by the time it reaches Alberta, Canada, Montana area, you're probably already going to see an 8.5 earthquake here. Probably an 8.5 earthquake here in this region, all the way down to the south. By the time it reaches North Dakota, South Dakota, Minnesota, this is probably going to feel like a 7.5, 8.0 earthquake here. As the energy moves eastbound, by the time it hits the Great Lakes, Ontario, Canada, Quebec, Canada, Nova Scotia, by the time it reaches the East Coast, the energy is going to dissipate to maybe a 6.5 to 5.0 earthquake as it reaches the East Coast. This energy is going to dissipate all the way across the continent. But the entire continent is going to shake. This Cascadia earthquake, the Cascadia megathrust earthquake, is going to make the earth ring like a bell. It's going to make the earth ring like a bell. I want to make sure everybody understands that. Just for kicks and giggles, we're going to talk about the Pneumatic Fault tomorrow evening. Over here on the Pneumatic Fault, what do we have going on? What do we have going on? Over here on the east side of the fault, we have Tennessee here. Ridgely, Tennessee, on the east side of the fault. This is a 1.5 tremor. This is not the only earthquake to happen here on the Pneumatic Fault. Tomorrow I'm going to show you earthquakes that happen every day up and down the entire fault line. It's not just a 1.5 or 1.7 tremor here in Ridgely, Tennessee. We have 2.0, 2.5, 3.0, 3.5, upwards of 4.5 earthquakes every day here on the San Andreas Fault. 3 years ago, that was not the case. 3 years ago, we could see measurements of tremors, 1.0 to 1.9. The Cascadia and the Pneumatic Fault have increased. The San Andreas Fault and the Pneumatic Fault have increased in size. Mean seismicity. Earthquake size has increased here. It has not decreased, it has increased substantially every day. Every day. Now, instead of seeing tremors, we're seeing minor earthquakes and small and moderate earthquakes as well, up and down the entire Pneumatic Fault. I want to make that perfectly clear. As I pointed out last week, over here in the Tennessee seismic zone to the east, we're seeing earthquakes here in Knoxville, Tennessee. 6 miles east-northeast here in Knoxville, Tennessee. This is on the Eastern Continental Divide here. Today we're seeing a 2.2 earthquake here in the Eastern Continental Divide here in the Eastern Tennessee seismic zone. I've shown you earthquakes before here even last week. The Tennessee seismic zone is alive and well. The reason that is because we have major events happening here in the Atlantic Ocean that nobody talks about. USGS never talks about it, rarely if ever. The North Atlantic seismic zone is moving. The Mid-Atlantic Fault is moving. It's expanding. The Mid-Atlantic Fault is expanding here, guys. What happens? As the Mid-Atlantic Fault expands, it's pushing Africa and Europe in an easterly direction. Pushing Africa and Europe in an easterly direction. At the same time, it's pushing North America, Greenland, Canada, and northern Mexico in a south-southwesterly direction. It's putting pressure here on the East Coast. Putting pressure here on the East Coast. As a result, the East Coast is also having earthquakes. We don't talk about it very often, but they are. Anywhere from 1.5 tremors on up to 3.5 earthquakes here on the East Coast. On the East Coast. A few years ago here in Washington and Virginia, they had a 7.1 earthquake here. 7.1 earthquake here on the Eastern Continental Divide. Shook this entire region. Shook the entire region all the way up to New York and Pennsylvania and Massachusetts. We're going to see that again soon. I have a feeling we're going to see it very soon. Getting back to the San Andreas Fault. Let's go here and talk about it now. Okay? You notice I got a headset in my ear. I'm monitoring earthquakes in Japan. As these seismic events happen in Japan, I'll talk about it, as I have during this entire broadcast. Let's go over to the San Andreas Fault here. Los Angeles County. Go to LA. This is Bakersfield. This is out east of Los Angeles and Bakersfield, out in the desert. What could happen here? What could happen here in Bakersfield? Look at all this seismic activity here. The seismic activity recorded here in Bakersfield. This was a Japanese earthquake. This was a 7.6 earthquake in Japan. Recorded here in Bakersfield, California. Prior to that earthquake hitting, you saw tremors here and minor earthquakes. Tremors and minor earthquakes. The top line here is 4 a.m. on the black line. Jumping down here to 5 a.m. 5 a.m. on the left-hand side. We come across to 1, 2, 3, 4, almost 5 minutes after 5 this morning. We see tremor activity. 1.4, 1.5 tremor activity here in Bakersfield, California. After 5:18 on the red line below that, this is another 1.5, 1.6 tremor. About 5 minutes later, we have another 1.4 tremor, Bakersfield. Then we see minor 1.0, 1.2, 1.3 tremors happen after that. Then we see the Japanese earthquake here. Heidi Pitrick just gave us a $10 super chat. Thank you very much for that, Heidi. God bless you for that. We appreciate that very much. Guys, you can give us super chats here that will go over to YouTube that will pay us money at the end of every month. We appreciate that very much. After 8 a.m. this morning, you see more activity here on the San Andreas Fault here in Bakersfield. Mostly tremors. Most of them are all tremors. However, there are at least two 2.5, 2.6 earthquakes here. There are at least two 2.5, 2.6 earthquakes here. The last one here at the bottom, at the blue line on the left-hand side, that's 12:30. We come across 1, 2, 3, 4, 5, 6, 7, 8, 9 minutes later. 12:39 p.m. this afternoon. 2.5, 2.6 earthquake here. Bakersfield, California. Okay, let me show you the next one here. Let's go over to Cabazon. Cabazon on the San Andreas Fault. Look at this. Again, we see over here just before 7:30. About 6:30 this morning, 6:30, 7:30, 7 o'clock this morning. You see the Japanese earthquake. But prior to that, you see tremor activity echoing up to 2.0 earthquake. Long-term tremor activity echoing up to 2.0 earthquake. And after that, the same thing. Notice after 10:30 on the blue line down here near the bottom. 10:30 over on the left-hand side on the blue line to the right. It starts at 10:33 and goes over through 1, 2, 3, 4, 5 minutes later. 5 minutes of tremor activity echoing up to 2.0, 2.4 earthquake. Maximum of a 2.4 earthquake here. This is a San Andreas Fault, your Cabazon. Okay, Cabazon. San Bernardino County. Let's continue here. Let's go just north of Lake Elsinore, Orange County. Orange County, guys, look at this. We just saw this happening about 2 months ago. Seismic activity in Orange County, California, north of Lake Elsinore. Look what we're having here. Up at the top, yes, we're seeing some tremors. At 4:15 this morning on the left-hand side of the red line, we see our first 2.0 earthquake here. We see tremor activity. .2 over here in southeastern Alaska near Yukon Territory. Again, Saturday they had a 7.2 earthquake there. Just one more aftershock from that 7.2 earthquake in southeastern Alaska, Yukon Territories. Over here at 6 a.m. on the black line. 6 a.m. on the black line, guys. We see seismic activity here. A lot of seismic activity. Okay. See that thicker black line? That's an increase in seismic activity on the San Andreas Fault. On the San Andreas Fault. Actually, I'm sorry, this is not the San Andreas, this is San Jacinto. No, I'm sorry, this isn't the San Jacinto either. This is the Elsinore Fault. This is the Elsinore Fault here. Increased seismic activity. Then we see the Japanese earthquake here. But after the Japanese earthquake quit shaking, or stops momentarily anyway, we see moderate earthquakes. Moderate earthquakes here, guys. We see, I'm sorry, not moderate. These are minor earthquakes. Minor earthquakes, not moderate. We see 2.0. We see 2.5, upwards of 2.6, 2.7 earthquakes here. On the blue and the red lines here. Let's go down to the blue, on the red line, the bottom right. The bottom right on the left hand, the bottom red line on the left hand side would be 12:15. Over here on the right hand side, this is 12:29 p.m. this afternoon. 2.6, 2.7 earthquake. 2.6, 2.7 earthquake here on the Elsinore Fault. Ivy Glen, California, just north of Lake Elsinore on the Elsinore Fault here. That's news. That's big news. The Elsinore Fault is alive and well. It's moving. It's moving hugely. Before, about 3 weeks ago, it was dead. Seismically dead. Now it's picked up. It's picked up. Let's move over to another location, this time on the San Jacinto. This is over in Hemet, California. Again, we're seeing, this is the San Jacinto Community College here in Hemet, California. Again, we're seeing the Japanese earthquake here. This is also on the San Jacinto Fault. This is all tremor activity. All of this is tremor activity except for the Japanese earthquake. Okay, let's go out to the San Andreas Fault near Rancho Mirage, California, out in the desert. Look at this. Between 4 a.m. and when this earthquake in Japan hit, all we had is very minor tremor activity. The greatest earthquakes were happening were 1.0, 1.2 tremors at all. But look over here on the screen line after 9 a.m. On the left-hand side, you see 9 a.m. on the black line. Move down to the green line. The green line on the left is 9:45. Move over almost 4 minutes later. We have a 1.4, 1.5 tremor here. The same thing happens over here on this red line near the bottom. The red line on the left is 12:15 here. Here in the middle, this is 12:23 p.m. this afternoon. Another 1.5 tremor here. Rancho Mirage on the San Andreas Fault. Okay, let's continue moving down. I want to take you over the desert, over to Victorville. One of our own family members, Isaiah's granny here, lives in Victorville. This is also right directly on the San Andreas Fault. Look what's happening here. Over here in this red line, on the left-hand side of the red line is 4:15. This is just before between 4:19 and 4:20 a.m. this morning. 1.2, 1.3 tremor. Then after 4:50 this morning, we have more tremors here. 1.3, 1.4, 1.5 tremors here. Then we have the earthquake in Japan. After the Japanese earthquake quit shaking, we see over here at the 9 a.m. point here on the left-hand side, we see another 1.6, 1.7 tremor. After that, we see more tremor activities. This is what happens on the San Andreas Fault here in Victorville, California, east of Los Angeles. This is east of Los Angeles on the San Andreas Fault. Okay? Now let's go down further south. Okay? I want to go into Los Angeles area. I want to go over to Los Angeles area. East of Los Angeles in Chino, California is what we see here. Chino, California. Just prior to the Japan earthquake, all we had were tremors here. But after that, the tremors got larger. Tremors got substantially larger, going up to 1.5, 1.6 tremors. This is good. this good-sized energy on the San Andreas here in Chino. Okay? Now, 6 months ago here in Chino, we were seeing minor earthquakes, 2.0, 2.9 earthquakes here in Chino, California. Also, earlier this year, we had 3.0 earthquakes here in Chino, California. Happening. Seismic energy is still going on here in Chino, California. Okay, let's continue this. I want to go over to north of Los Angeles to a town called Del Amo. Look at this. This is pretty typically what we've been seeing here in Del Amo all along. Prior to this Japanese earthquake, the earthquake in Japan, we see a lot of tremors. We've also seen our beginnings of minor earthquakes here as well. Over here after 6:15 a.m. in the morning on the left-hand side, we go over here to the right. Approximately 6:25 a.m., we see our first 2.0 earthquake here. Multiple earthquakes. You see that big blob of red there? Multiple 2.0 earthquakes right there. But you see the stylus here that's recording this earthquake. It's bouncing all over the place. Energy here was building up for the earthquake in Japan. After the earthquake in Japan hit, the stylus here is bouncing all over the place. This is not the San Andreas fault. This is over in Los Angeles. One of the many faults here in Los Angeles is shaking. This is all minor tremor activity except for maybe two. Over here on the right, on the blue line. This blue line here after 11:30 this morning on the right-hand side. This is 11:44 a.m. this morning. 11:44 a.m. this morning. This is our first 2.5 earthquake here. First minor earthquake here. Now, there may have been more larger seismic activity in terms of minor earthquakes, 2.0 to 2.5 earthquakes here in this area. Throughout this sidewind, you see a lot of color. Every minute of every hour, you see activity here. We may have seen some other 2.0 activity, such as after about 11:03 this morning. On the left-hand side, you see another group of earthquakes, very blue area. This is also, I believe, 2.0 earthquake as well. Okay? These earthquakes continue happening in Los Angeles area, all over here. Primarily for the next few minutes, I'm going to be talking about LA, Los Angeles. This is Ellis, California, just north of Los Angeles as well. Before the Japan earthquake, we had a bunch of tremors. But after that, 8 a.m., 8:30 a.m., we had some tremors building into minor earthquakes here. On the blue line here after 9:30. On the left-hand side, we have 9:30. Over here on the right-hand side, we have 9:43 a.m. this morning. This was a 2.6, 2.7 earthquake, minor earthquake here this morning. 9:43 this morning. Then we have more activity after that. At 10 o'clock on the black line, this is more accentuated seismic activity, mostly tremors. 1.4, 1.5, 1.6 tremors here, all the way across this black line here, off and on. Then on the next red line on the bottom left, on the left-hand side here. That next red line is 10:15. Again, it's gone down to 1.2, 1.3, and all the way up to 1.4, maybe 1.5 tremors after 9:15 or 10:15 this morning. Then after 10:45 on the green line here, you see more earthquake activity. These are tremors, 1.3 to 1.6, 1.7 tremors here, all the way across this green line here to the right. Then we see more activity after 11:30 on the blue line. Tremor activity. 11:45 on the green line, more tremor activity. 12 noon, more tremor activity building up to 1.6, 1.7 tremors. Then over here on the far right on the bottom blue line, we have 1.2, 1.3 tremors building up again to 1.6, 1.7 tremors here. Ellis, California. Occasionally here in Ellis, we will see a minor earthquake here. 2.0 to 2.9 earthquake here in Ellis, California. Now, we may have had that today. It may have happened today over here on the blue line after 9:30 this morning. Over here at 9:43. 2.5, 2.6 earthquake here, I believe. Minor earthquake activity here in Ellis, California. Let's continue here in Los Angeles. Let's go over to east to Fontana. Fontana is just west of the San Andreas Fault near the San Jacinto. Between the San Jacinto and the San Andreas, look what's happening here. Up at the top before the Japan earthquake hit. The top line here on the left-hand side is 4 a.m. in the morning. We come over here just after 4:04 this morning. We have our first 2.0 earthquake. 2.0 minor earthquake. Then on the blue line, we have some tremors. The green line, more tremors. On the next black line after 5 a.m., we have tremors building into minor earthquakes. Tremors building into 9 point. Tremors building into 2.0, 2.5, 2.6 earthquakes. On the black line there, it's after 6 a.m. After 6:15 on the red line, you see more tremor activity building up to 1.9, 2.0 earthquakes. Over here in the center right, this would be about 9:21 a.m. this morning. I'm sorry, 6:15, 6:21 a.m. this morning. 2.3, 2.4 earthquake here. 6:23 this morning. Then you see the earthquake in Japan. After that, what happens? All of a sudden, we go from minor earthquakes on up to 3.0 earthquakes. On up to 3.0 earthquakes. At approximately 10:32 a.m. this morning. 10:32 a.m. this morning, we have our first 3.0 earthquake. 3.0 earthquake here. The next 3.0 happens after 11:15 here on the red line here. 11:23 a.m. here in the center right. 3.0 earthquake here at 11:23 a.m. this morning. Further over here to the right, at 11:28 a.m. this morning on the red line. 3.0, 3.2 earthquake here. 3.0, 3.2 small earthquake here. This is a common stance here in Fontana. We've seen many 3.0 earthquakes here in Fontana before. They're going to continue. This is right next to the San Andreas Fault and right between the San Jacinto, Fontana, California. Okay. From there, let's go over to the beach, South Los Angeles, Laguna, California. Laguna, California here at the top, 4 a.m. this morning, we see tremor activity. 1.0, 1.2, maybe 1.3 tremors going across the top. Occasionally got larger to 1.3, 1.4 here before the earthquake in Japan. Then the earthquake in Japan hit. Then we see more activity here. Tremors all over the place here along the beach line of Laguna Niguel, California. Laguna Niguel, California. Let's continue here. I want to take you over to Long Beach. Long Beach. Look what's happened here. This is very typical here in Long Beach. Every day. Everything I'm showing you here in Los Angeles happens every day. Every day, all day long. Look what's happening here. Up at the top, 4 a.m. in the morning. This is Pacific time again. All times here in California are Pacific this morning. We have tremors building up to 1.9 tremors. Then we have the Japanese earthquake. Then after that, it becomes all color here. Wall-to-wall color, top to bottom. Here we begin to have 2.0, 2.5, 2.6 earthquakes here in Long Beach, California. This seismogram is called light hype, Long Beach, California. Look at the bottom here. We're going to look at the bottom blue line and the bottom red lines. Over on the right, the bottom blue line on the left-hand side is 12:30 this afternoon. Over here on the right, we're talking about 12:40 this afternoon. 12:40 to 12:44 on the far right. Here we're seeing tremors. We're also seeing minor earthquakes, 2.0 earthquakes here. Minor tremors and 2.0 earthquakes here in Long Beach. Then we go over here to the green line on the left-hand side. Again, we're seeing tremors and minor earthquakes here. 2.0 and upwards of 2.8 earthquakes. Look at this earthquake after 12:47 this morning. 12:47 this morning. This green line goes farther down. This was at least a 2.7 earthquake here. 2.7 minor earthquake. Most of the rest of these are also 2.0, 2.3, 2.4 earthquakes. This is typical here in Long Beach. Here in Long Beach, we've seen as high as 3.0, 3.5 earthquakes here in Long Beach during the past year. During this past year, we've seen upwards of 3.0, 3.5 earthquakes here in Long Beach. Fact, we've given you that information every time it's happened. Literally every time it's happened. Let's move forward. Show you more information here. Let's go to downtown Los Angeles. This is another important seismogram to look at. This seismogram comes from the building, the city-county building in Los Angeles, that great big, huge, probably 30-story high building in downtown LA, where LAPD headquarters is. It's also where the emergency management office is for City County of LA. The bottom floor, the basement of the facility is where this seismograph is located. Look what they're showing here. Literally nothing. They're showing some very minor activity here in Los Angeles when it comes to the Japan earthquake. Hardly showing anything. That means they have doctored the seismograph. They doctor the seismographs, guys. They turn the seismographs down. They also doctor the seismographs, the readout. This is a computer readout called a seismogram. They doctored it. They're not showing any activity here. That's a falsehood. That's a falsehood. Up until now, you've seen every seismogram showing the Japan earthquake. This one, it's not doing it. They're hardly showing any activity at all. This seismograph is basically off. They've turned it down so they don't have to explain anything going on. They turned down the electronics of the seismograph so they don't have to explain what's going on here in Los Angeles. I've shown you all kinds of activity today here in Los Angeles, and downtown, they're not showing anything. That means they've doctored the seismograph. They played with it. They've doctored, they've erased data off the seismogram itself. They do this frequently all day long, all over the United States and elsewhere. They doctor it so they don't have to prove anything going on. Oh, nothing's going on. Nothing's going on. I've had seismologists from the USGS say nothing's happening in Oregon. Nothing happens in Oregon any day. Never any day. Bullcrap. I call bullcrap on that. On Wednesday, I will show you all kinds of information pertaining to the Cascade earthquake. Oregon is filled with activity. Oregon and Washington and California are full of activity every day. They say there's nothing happening in Oregon. I call BS. It's happening, and I can prove it. I prove it day in, day out here. Okay? Let's go over to Mira Loma, also over on near the San Jacinto Fault. This near Loma Linda, California, guys. Look at this. Every seismogram I've shown you is showing the Japan earthquake, every one of them. Look what happens here in Mira Loma, just southwest of Loma Linda. Up at the top on the black line. Up at the top on the left-hand side, it's 4 a.m. in the morning. Here you've seen tremor activity. All kinds of tremor activity ranging in size from 1.0 to 1.4 activity. 4:15 in the morning on the red line, the same thing. Green line, the same thing, which is 4:45. Next black line, and every black line after that is every hour. Every hour. 5 a.m., more tremor activity. About 5:21, we had 1.5, 1.6 tremor activity here in the red line in the middle there at the top. Then we have the Japan earthquake hit. You see the activity. Then after the earthquake simmers down, we see more activity here in Mira Loma itself. Let's look down here at the bottom line here, the bottom black line. The bottom black line here is 1 p.m. today, 1,300 hours on the black line. We come over here to the right, 1:03 p.m. this afternoon. 1:03 p.m. this afternoon, we have a first 2.5 earthquake here. 2.5 earthquake here in Mira Loma. In the past months, we've seen 3.0 earthquake activity here in Mira Loma, on the San Jacinto and on the San Andreas Fault. Happened. We've proven it time and time again, all day long. All day long. Let's keep going here. I want to show you Moore Park, north of LA. Look at this. This is very typical with Moore Park. Moore Park is a town of maybe 25, 50,000 people. Between 25 and 50,000 people. That's a great population area. I understand. It's probably closer to 50,000 people. Here in Moore Park, we've seen tremors. We've seen minor earthquakes, 2.0 to 2.9. We've also seen 3.0 activity, small earthquake activity here in Moore Park, California. Up on the red line here just after 5:15 this morning. About 5:17 this morning. This is a 2.4 earthquake. 2.4 minor earthquake on the red line here. After that, we see more tremor activity and we see the Japanese earthquake. After that, we see more tremor activity here in the Moore Park activity here. On this red line after 8:15 this morning. Here we're at 8:18 this morning on the red line. I believe that was probably a 2.5, 2.6 earthquake. After that, on the blue line after that, that would be 8:30 on the left-hand side here at 8:31 on the blue line. Another 2.3, 2.4 earthquake. Then we come over here to the right and down. You see tremor activities, and down here on the next red line after 10 a.m., this will be 10:18 a.m. this morning on the red line. 2.5, 2.6 earthquake here. Minor earthquake. Then you see tremors and minor 2.0 earthquakes here. But what happens here later this afternoon? On the red line here after 12 noon. The red line here on the left-hand side will be 12:15. We come over here to the right. Okay? Suddenly we're over here at approximately 12:26 p.m. this afternoon. 12:26 p.m. this afternoon, guess what? We have a 3.0, 3.3 earthquake. 3.0, 3.3 earthquake, and it may have been multiple 3.0 earthquakes back to back. This happens all the time here in Moore Park. This happens multiple times every day here in Moore Park. A 3.0, 3.3 earthquake here in Moore Park today. Immediately after that, a minute later, we have another 2.8 earthquake. 2.8 earthquake on that red line. We have tremor activity after that. Then on the blue line after that, we have more seismic activity, mostly tremor activity after that, after 12:30. 12:45 on the green line. 12:45 on the green line, we have more tremors, and also we have some minor earthquake activity. This happened at approximately 12:51 p.m. this afternoon, a 2.0 earthquake there. Then again at 1 p.m. on the black line on the left-hand side, more tremor activity here. Yes, typically we see tremor and minor earthquakes here in Moore Park, and today we saw another 3.0. Yes, we've seen 3.0 activity here before. 3.0, 3.9 activity are small earthquakes. Small felt earthquakes here in Los Angeles. Yet, the LA mayor and other people say, oh, it doesn't happen. Yes, it does. This is where you see it. You have to go to the data sheets. You have to go to the seismic to see it. These earthquakes do happen on a frequent basis every day. Every day. They can deny it, but the proof is in the pudding here, as they say. I want to go over also north of Los Angeles to a place called Pardee, California. Look at this. Look at this. Up at the top on the black line is 4 a.m. on the morning on the left-hand side. We go over about 5 minutes later. This is a 2.7, 2.8 earthquake on the black line there. You see tremor activity after that, up to maybe even a 1.6, 1.7 tremor. Then we come down to just after 5 a.m. on the left-hand side, on the black line. 5:01, between 5:01 and 5:02 this morning, we have our first 2.0 earthquake. On the next black line, on the next blue line on the left-hand side is 5:30. Over here on the far right, we have another 2.0 earthquake here at the far right. 5:44 this morning. Interesting. Renee Sepi just joined us as a member of our program. Down in the program description right below this video today, the top of the program description, you can find a link to our members chat here. You can join the EMA family on the members only chat for as little as $1.99 a month. Renee Sevi just joined as EMA 1. That's $2.99 a month. No, it's not. It's $3.99 a month. $4 a month. For as little as $1.99 to $4.99 a month, you can be a member of our EMA members family. We'd appreciate that. Thank you, Renee. God bless you for that. We appreciate you. Renee Sepi is one of our moderators here on the chat. We love her a lot. Appreciate you. Thank you, Renee. God bless you. But down here, further down here this morning, actually after this afternoon, this after 12, 16, 17, 18, 19, 12, 20 this afternoon. 12:20 this afternoon, this red line, we have our first 3.0, 3.2 earthquake. 3.0, 3.2 earthquake here in Pardee, California. We haven't seen 3.0 earthquakes here in Pardee for about a month or so, but they do happen. They do happen. Up at the top, we saw 2.8, 2.9. This is a 3.0, 3.2 earthquake here. Small earthquake here. Pardee, California. We don't end here. Let's continue this. I want to show you Pasadena, guys. Pasadena. Look what they're showing here. Nothing. Nothing at all. This is JPL seismograph in Pasadena, California. They're showing nothing. They turned the seismograph off. They turned the seismograph so far down, it's not recording anything. I've shown you seismic activity all over the LA area, and here in Pasadena, they're not showing a thing. Caltech and USGS shut down the seismograph. This is horrific. This is blasphemy. We know for a fact all over Los Angeles there's activity. For them to shut down the seismograph here in Pasadena is horrific. They ought to get spanked for that. They ought to get spanked for that. No, I'm not calling for violence at all, but they need to be punished for that. That's horrific. I want to show you that because they don't even show the Japanese quake. That's blasphemy. Let's go up to the north coast of Los Angeles, La Playa del Rey. La Playa del Rey, Marina del Rey area. Look at this. Look at this. Again, all we're seeing here is very tiny tremor activity up until the quake in Japan. Then we see what happened after the quake in Japan. After the quake in Japan subsides, then we have more tremor activity here. That's pretty much normal in Playa del Rey, Marina del Rey area here on the northwest coast of Los Angeles. This is pretty typical. However, we have seen minor earthquakes here in Playa del Rey, Marina del Rey. By the way, guys, this marina here, here in Marina del Rey, Playa del Rey, there are very expensive homes. $1 million worth of homes here. They have yachts. They have sailboats. All kinds of marine activity happen here in the marina. Here's where we have tremors. Yes, we do have minor earthquakes here in Playa del Rey, Marina del Rey area. All they show here are tremor activity here today. Let's continue here. Let's go over to closer to Los Angeles City here. This is Rinaldi, California. Here we've seen minor earthquakes before. Here we're just seeing tremor activity as well as the Japan earthquake here. Tremor activity here in Rinaldi, California. Let's go on here. Let's go to Rio Hondo. Rio Hondo. Look at this activity here. Guys, yes, before the Japan earthquake here, you're seeing all kinds of seismic activity. What is this? As I pointed out before, the seismograph is picking up activity from molten magma beneath the surface. Molten magma headed for a volcano over in Los Angeles area. I'll point out that volcano in just a minute. The seismograph here is picking up molten magma traveling through magma channels beneath the earth we're walking on, picking up seismic activity from the magma headed towards the volcano. You're going to be surprised when I show you the volcano in just a minute. This is Rinaldi. Yes, in Rinaldi, before we've had minor earthquakes. We've also had plenty of tremors, as you're seeing here today. But we're also seeing magma on the move headed towards the volcano east of Los Angeles. Unreal. Wait for this, guys. This may blow your mind here. This may blow your mind. Before we go to the volcano, I want to show you Anaheim, California. This is Disneyland, guys. This is Disneyland. Okay? This is what they call the State Street seismograph. The State Street seismograph. This seismograph shows you nothing but tremor activity. Nothing but tremor activity except for one area. One earthquake. One good-sized earthquake here. On the second blue line on the right-hand side center. Look at that earthquake. 2.93 points earthquake here. 2.9, 3.0 earthquake here. This is at 5:39 a.m. this morning. 5:39 a.m. this morning, a 2.8, 2.9 earthquake here in Anaheim, California. In Anaheim, California, we've seen minor earthquakes all the time. All the time, literally. Yes, we see tremors as well. But we've also seen 3.0 activity frequently. Every time they approach 3.0 activity, Disneyland and Knott's Berry Farm has a stop operation of the roller coasters. They have to stop operation of the roller coasters to make sure they check the track, make sure it's still viable for people to get on the roller coaster and go down their mountains. Okay? Here we have a 2.8, 2.9 earthquake approaching a 3.0. But this is early on before they even open. I believe they've had plenty of time before they open to check the roller coaster track to make sure it's okay. There is a seismograph in that location recording this information. That's what you're seeing here. 2.8, 2.9 activity at approximately 5:39 a.m. this morning. Other than that, you see tremors all day long, literally all day long. That's not normal here at State Street. Normally we see tremors, minor earthquakes all the time, every day. Literally every day. Let's keep going here. Now I want to show you the Baldwin Hills. Northwest of Los Angeles, they have an oil and gas pumping region. They call it the Baldwin Hills. It used to be a mountainous region here northwest of LA. They bulldozed the mountain down. They knocked down all the trees, bulldozed it completely down. Now they have an oil and gas pumping operation going on here. Oil and gas refinery going on here in the Baldwin Hills. Here in the Baldwin Hills, all you see are tremor activity. Very minor tremor activity every day, except sometimes we see minor earthquakes here. Whenever they have an earthquake here in Los Angeles, all of a sudden, the pumping operation almost stops. Almost. The oil pressure goes down in the pumping rig. Every time they see an earthquake here in Los Angeles, the oil pressure at the rig goes down every time. I verified it with the oil and gas companies here that pump this oil and gas out of the ground. The pumping pressures go down every time there's an earthquake here. Here, all you see are tremors here, fortunately. You're also seeing the Japan earthquake here. Baldwin Hills, California, northwest of Los Angeles. Let's go further to the east. Okay? Now I want to show you University of Los Angeles, University of Southern California, LA. Right here. Look at this. This is another fault seismograph. How do we know? Because folks are not showing anything. They're not showing the Japan earthquake at all. That makes this seismograph completely false. Completely false. I would love to have shown you this with all this activity at the bottom. Those were tremors. Those could be mostly tremors. But considering that the Japan earthquake is off the seismograph completely, doesn't show it on the seismograph, that means this whole seismograph is false information. False information here. Caltech and USGS ought to get spanked. Putting up false data again. They do it too many times. They do it all the time, literally. Let's go over to the volcano in Los Angeles. Walnut, California. Walnut, California. I showed you the other earthquake, the other seismographs. That seismograph showed you what's going on. Showed you magma flowing to this volcano here, Walnut, La Puente. Two cities here in the caldera of the volcano. The caldera is the hardened lava rock from the last time this volcano erupted, the caldera floor. Okay? They built 2 cities on top of the caldera. What you're seeing here are earthquakes from down beneath the caldera, down inside the volcano. Down inside the volcano. Let me bring up our webcam and let me show you what's going on. The caldera floor is lava rock. Lava rock, guys. What happens? When that volcano last erupted, the lava rock, the molten magma hardened into a piece of lava rock. Very deep lava rock here. Huge lava rock. But this lava rock has magma underneath it. It's pounding on the lava rock like this. Pounding on the lava rock like this. When that happens, cracks develop in the lava rock. Cracks develop in the lava rock from the pounding of the magma beneath it. When those cracks open up, they open up holes, don't they? The holes allow gas to leave the volcano. They allow carbon dioxide, these cracks allow carbon dioxide and sulfur dioxide to escape the volcano. Why? How? 67% of all magma is water. 67% of all magma is water. So when these cracks develop, it allows the vapor, the water vapor, to escape the volcano. This water vapor contains sulfur dioxide, smells like rotten eggs, and carbon dioxide, which is odorless. Residents have complained here in Walnut La Puente for years now that they're smelling rotten eggs. It's because they built these cities on top of the volcano. Now you're seeing earthquakes here. Look at these earthquakes, you guys. Look at these earthquakes. Let me enlarge this segment so you see what I'm talking about. Up at the top on the black line, okay, 5:01 a.m. this morning. Prior to that, we see some tremors to build up to 2.0 earthquakes, and then they build up to at least a 3.0 earthquake. Notice on this diagram, they chop the top and the bottom of the earthquake sequences off. That means these earthquake sequences are larger than they're saying they are. Right here, we're seeing at least a 3.0 earthquake, and they're larger than that. Possibly even as large as a 3.5 earthquake. Imagine magma every day pounding on the caldera, pounding on the underside of the lava rock, causing earthquakes. That's what people are feeling here. That's what people are feeling here every day. After that, here on the red line, you're seeing tremors and minor earthquakes happen. Tremors and minor earthquakes up to maybe 2.0 earthquakes. On the blue line after that, you're seeing more tremors and 2.0 earthquakes here. Then on the next green line, on the left-hand side would be 5:45 in the morning. Over here on the right, we go 1, 2, 3, 4, 5, almost 6 minutes later. 5:51 a.m. in the morning. On the green line here, we see a 3.3 earthquake. A 3.3 earthquake here at Walnut La Puente. What happens after that? At 6 a.m. on the black line, you see tremors. We go over here to 6:04. 6:04 in the morning, we see another 3.0 earthquake happening. The top is cut off. We don't see the bottom because we see more seismic activity after that. That covers the bottom of this earthquake sequence. Another 3.0 earthquake here, at least. Then we have the Japanese earthquake, and right in the middle of the Japanese earthquake, what happens? Then we get another earthquake sequence here in Walnut La Puente on the red line. After about 7:18, 7:19 this morning. 3.0 sequence again cut off at the top and the bottom. Meaning this earthquake here was over 3.5 small earthquake. Over 3.5 small earthquake, maybe larger. This earthquake could have been a 4.0 moderate earthquake. Could have been a 4.0 moderate earthquake here. This earthquake sequence was also almost 3 minutes long. Almost 3 minutes long. Prior to that, these other two sequences were 2 minutes long. This is 3 minutes long. 3 minutes long being a 3.0, 3.5 earthquake, that's crazy. Could have been also 4.0, that's even crazier. Moderate earthquake causes moderate damage. Pictures and things falling off the walls. Knickknacks and books falling off the shelves. We saw what happened over in Japan today. We even see pictures on ceilings waving in the wind. Also, we see dishes and plates and cupboards and even glasses rattling around in the cupboards. They aren't secured by child latches on the cupboard doors. They fall out of the cupboard as well, especially when earthquake energy lasts for a period of time. That's what's going on here. Then again, after 9 a.m., 9:45 a.m. on the left green line here. This would be 2.7, 2.8 activity here. We come across to the next black line, being 10 a.m. on the left-hand side. We come across here to the right. Here on the right, we have activity here that's at approximately 10:11 a.m. this morning. 10:11 a.m., we have another 3.0 earthquake here. The top and the bottom are cut off here, the same as the others. This means this earthquake was over 3.0, maybe 3.3 earthquake here, I imagine. This earthquake activity didn't last any more than like 60, 70 seconds. Okay, after that, you see tremor activity until we get down here to 10:15. 10:15 over on the left-hand side. 10:16, we see another 3.0 earthquake. 3.0 earthquake that lasts maybe 45 seconds, off and on. We come over to the right again. This one is at 10:21. Another 3.0 earthquake that lasts about 45 seconds. Look at this. Then at 12:30 on the left-hand side, come over here to the right. We're now at 12:41 a.m. this morning, or 12:41 p.m. this afternoon. Another 3.0, 3.3 earthquake. 3.0, 3.3 earthquake lasts about 50 seconds. Then here on the black line after 1 p.m. You see tremor activity over here on the right-hand side at approximately 1:05, 1:06 this afternoon, 2.0 minor earthquakes. 2.0 may be building up to 2.5, 2.6 minor earthquakes today. Usually we have large earthquakes here, meaning 3.0, 3.5 earthquakes, a lot of them. Normally 5 to 7 earthquakes here every day, every morning. Every morning. Walnut and La Puente. Walnut and La Puente, California. Let's go down into Imperial Valley. Let's go down into Imperial Valley. Actually, before that, let's go down to San Diego County. I want to go down to southeast San Diego County, just north of the U.S.-Mexican border. Look at this. This is a place called Campo Elementary School, Campo, California. Here we're seeing tremor activity, all kinds of tremor activity. We're also seeing this Japanese earthquake. You're also seeing these slanted lines. These slanted lines are due to the seismologists not paying particular attention to the seismograph. If this scientist was paying attention, the seismologist would have paid attention. These lines would be completely straight, left to right. They're not. But we're seeing tremor activity. Lots and lots of tremors here in Campo Elementary School in southeast San Diego County. Let's go to Imperial County to the east. Just to the east of San Diego County. want to show you what's going on. Think you might get blown away. Let's go down to the town called Bombay Beach. Remember Bombay Beach? Usually we see anywhere between 5 to 7 earthquakes a day, 3.0 larger every day. This didn't happen so much today. Today we're showing you at least 3.0 earthquakes, maybe 4. Maybe 4 3.0 earthquakes and larger. But we're also showing the Japan earthquake before that. Prior to the Japan earthquake, we have tremor activity. Usually from the very outset every day here in Bombay Beach, we have 3.0, 3.5 activity. I believe that's what we had here in Bombay Beach today. Every day this happens. Every day. It doesn't go without a day to have it happen. Every day. Let's go over here to the town of Imperial, like I told, actually before that. I want to show you, as I said before, the San Andreas Fault goes down the east side of the Salton Sea. It goes underneath the Salton Sea near the southern part of the Salton Sea. Then it comes back out at Calipatria, California. Look at this. Look at this, guys. Again, this happens every day in Calipatria. Every day in Calipatria. This is a USGS seismograph. USGS seismograph. This starts off at 2 p.m. yesterday afternoon. Yes, here we're seeing 2.0, 2.5 earthquakes. 2.0, 2.5 earthquakes on these lines, these vertical lines. The red part of the vertical line is computer generated. The computer generates these red lines to make sure the seismologist sees these earthquakes. The red lines make the seismograms stick out. These are earthquakes. 2.0, 2.5, sometimes 2.7 earthquakes here. There are about 20 earthquakes here in this area. 20 earthquakes between 2 p.m. and 10 p.m. in an 8-hour period. 8-hour period, 20 earthquakes. What happens after 8 p.m.? The seismologist, before he leaves at night, turns the seismograph down. So between 8 a.m., between 8 p.m. and later in the morning. Let me enlarge this so you can see the time here. From 8 p.m., actually from 2200 hours, which is 10 p.m. last night, 10 p.m. last night until 4 a.m. this morning. 6 hours. 6 hours this seismograph is turned down. 6 hours this seismograph is turned down. Not registering much of activity at all. You see some tremor activity here. These tremors probably were larger tremors, but it's not registering here on the seismograph. Why? Because the electronics are turned down. These must have been larger tremors because otherwise they would not even show up here. Meaning the seismograph was turned down so far, it's just barely registering any kind of activity. These were larger tremors here, possibly even 2.0, 2.5 earthquakes here in Calipatria during the nighttime. After 4 a.m., what happens? After 4 p.m., what happens? 4 a.m., we see more tremors, 1.6, 1.7, even up to 2.5 earthquakes here. 2.5 earthquakes. Then what happens here this morning? Here you see these sticker lines here. These sticker lines mean we have earthquakes here. Felt earthquakes. Felt earthquakes. Let's take, for instance, this one earthquake here in the center left-hand side. This happened after 6:30 this morning. It's about 6:40 this morning. This red earthquake generates its thickness. That means this earthquake lasted about 30 seconds. 30 seconds, judging from its size as it is right now. This was a 2.6, 2.7 earthquake. But again, they cut off the top. We can't see the bottom. They cut off the top and they cut off the bottom. This was a 3.0 earthquake here. 3.0 earthquake. Then, after 6:30 this morning, we have a 2.5, 2.6 earthquake. Then we have a larger one. The thickest earthquake shows the time element here. Again, about 20, 30 seconds long, lasting 20, 30 seconds. Again, this is cut off at the top and the bottom. This would be a 2.5 or 2.5, 2.6 earthquake. The top and the bottom becomes cut off. That means this was a 3.0 earthquake here. They don't want us to know the strength of these earthquakes. Folks, before they started this several years ago, they started turning off the seismograph during the late night, early morning hours. Before that, these seismographs would show anywhere from 75 to 150 earthquakes a day. They were showing between 75 and 100 earthquakes a day. Unreal. Look what they're doing here. You see all these earthquakes here? The last anywhere from 10, 15, 30 seconds here. 2.7, 2.8, 2.9, 3.0 earthquakes here. Look at that. All of them. All of them, guys. All of them. This is a USGS seismograph. USGS ought to be ashamed of themselves. Right here in just this area here, between 4 a.m. and 10 a.m. Actually, it goes further than that. Actually, I'm right. Between 4 a.m. and 12 noon. Between 4 a.m. and 12 noon, we have 75 earthquakes here. 75 earthquakes. Go figure. What happens after that? Nothing. That's because they cut off the seismograph. They cut off the seismograph. That's typical. That's typical. In this case, this seismograph typically shows us at least 12 to 18 hours worth of work. 12 to 18 hours worth of work. This one goes from 2 p.m. yesterday afternoon until about 12 noon. Until about 12 noon. Let me enlarge this. I want to truly see what's going on here. Yeah, about 12 noon, 12:30. Meantime, we have multiple 3.0 earthquakes here. Multiple 3.0 earthquakes, guys. USGS should be ashamed of themselves. Turning off their seismographs so they don't see anything. So they don't have to report earthquakes. That's basically what this is about, not having to report earthquakes. They don't want to have to admit there are earthquakes here in the Imperial Valley. All day long, every day. All day long, every day. From here, let's go over here to Imperial. The town of Imperial here. Right here. Okay? These are Caltech seismographs here. Or Caltech seismographs. The readouts are computer readouts called seismographs. Here. Actually, this is Holtville. This is Holtville, I showed you earlier. Look what's happening here. Early in the morning, all we had were here tremors. Typical. Then we show you the Japan earthquake. But after the Japan earthquake, suddenly we go from tremors to minor earthquakes here. Tremors to minor earthquakes here this morning. Unreal. Unreal. Let me go over to the town of Imperial here. This is the town of Imperial here. Look what happens here. Every day here we have tremors, just like we see here. Then they show the Japan earthquake. Prior to the Japan earthquake, on the red line. The red line on the left-hand side would be 6:15. We come over 1, 2, 3, 4 minutes later. 4 minutes later, that's 6:19. We have tremors for about a full minute. Those tremors within the next minute become 2.0 earthquakes. 2.0 earthquakes here, prior to the Japan earthquake hitting. Then on this black line, underneath this black line, we see more Japan earthquake. But this black line is showing you earthquake activity here in the town of Imperial here. 3.0 earthquake activity here in the town of Imperial. Yeah. This is highlighted activity, guys. That means this earthquake actually occurred here in the town of Imperial. That's not surprising. 3.0 small earthquake activity occur here in the town of Imperial every day. Every day, without fail. Yes, they get tremors here. They get minor earthquakes as well. But every day, without fail, we have at least 1 or 2 3.0 earthquakes here in the town of Imperial. Let's go south to El Centro. El Centro. I love this. One of our own EMA family members lives here in El Centro. His name's Juanito. Juanito has been a member of our EMA family for years. He and his family feel these earthquakes every day. Look what happens here. Even before the Japanese earthquake, on the black line after 5 a.m. Go over here to the right. Over here on the right, this earthquake happened about 5:11 a.m. this morning. 5:11 a.m. this morning, we had a 3.0 earthquake. How about that? After that, we see tremors and minor earthquakes, 2.3, 2.4 over on the right-hand side on the blue line. That blue line here is 5:44 a.m. this morning. Minor earthquake. Minor earthquake. After that, you see the Japan earthquake here, nailing it, literally nailing it. The first activity we see after that is approximately at 8:15 this morning on the red line. The black line is hard to see because the Japanese earthquake continues shaking. But about 8:15 this morning, all of a sudden a 3.0 earthquake started to appear again. These 3.0 earthquakes here are linked together. That's because the seismograph links these 3.0 earthquakes together because these are magma related. Magma related here in El Centro. Magma is headed from the Pacific coast of San Diego all the way over here. Magma flows underground, underneath the ground we walk on. Comes over here to the Imperial Valley. Shows up here on the Imperial, on the El Centro seismograph. The magma is flowing over into the Sultan Butte volcano on the southern side of the Salton Sea. The Sultan Butte volcano over on the southern side of the Salton Sea, near the center of the Salton Sea. Okay? Look at all these 3.0 earthquakes here. We see another earthquake on 3.0 earthquake on the blue line here. That blue line is after about 9:35 this morning. Another 3.0 earthquake. Then after 10 a.m. on the blue line over on the right-hand side. 10:44 a.m. this morning, another 3.0 earthquake. multiple 3.0 earthquakes. And on the red line above that, 10:15 on the left-hand side, we go over 1, 2, 3, 4, 5, 6, which will be 10:21 this morning. We have another 3.0 earthquake. Yeah. How about that? How about that, guys? Then, look here on the red line on the bottom here. 12:18 this afternoon. Another 3.0 earthquake here. Then on the blue line here on the left-hand side, 12:30, another 3.0 small quake. Incredible, huh? It is. We go over further to the right, we have a 2.8, 2.9 earthquake here at approximately 12:41 p.m. this afternoon. Unreal. Then on the green line at the bottom, on the left-hand side, this would be 12:48 p.m. this afternoon. Another 3.0 earthquake here. Another 3.0 earthquake. Again, here in the town of El Centro, we have multiple 3.0 earthquakes every day. Somewhere between 10 and 20 3.0 earthquakes here every day in the town of El Centro. These earthquakes are felt earthquakes. And when we've been here in the chat and Juanito's been here, he's felt them here. Our moderator, Demon Catman, my friend Dean from the Southeast England, he says, wave to Juanito. Wave to Juanito, guys. I believe Juanito is probably watching this program. Sometimes he even comes up on the chat. We appreciate that a lot. Guys, this happens every day. The town and cities all throughout Imperial Valley are shaking. Towns and cities all throughout the Imperial Valley are shaking. For them not to say this is happening is a fallacy. It's a lie. It's an out and out lie. Out and out lie. Let's go over here to the USGS map again. I want to show you what it says here, down here in the Imperial Valley. They lie through their teeth here. Off the east coast of Honshu, Japan, they had another 5.7 earthquake. 5.7 earthquake 15 minutes ago. Off the coast of Honshu, Japan. This is the Imperial Valley. Up here to the north here on the northern shores of the Salton Sea, this is a small town called North Shore Salton Sea. Again, going down here on the east side of the Salton Sea, we have Bombay Beach, or the Salton Sea, where the San Andreas Fault goes underneath the Salton Sea here. Other than that, it runs alongside the east side of the Salton Sea. So it comes out down here in and near the town Calipatria. Over here in the Salton Sea here, in the Imperial Valley, we have a 1.8 tremor, and that is just north of, or east of, I should say, northeast of the Salton Butte volcano. The Salton Butte volcano is right there. Right there, guys. The Salton Butte volcano is right there. In the water. Now, occasionally during the winter month or the summer months, water evaporates from the Salton Sea. When that happens, you can see what looks like sticks sticking up out of the Salton Sea. Those are actually great big huge pins sticking up. Pins. Volcanic glass fingers sticking up out of the ground. Hardened lava. Volcanic glass. It's called obsidian. In the previous programs of this channel, I've shown you what's happened here at the Salton Sea, what's happened here at the Salton Butte volcano. Okay? Down here on the southern side of the Salton Sea, we also have thermal pots. Thermal pots here on the land. They had a highway right next to the Salton Sea here to the south. They had to reroute it. They had to back it off into Imperial Valley here. That's because the thermal pots kept moving. They would have damaged the ground. They would have damaged the highway. They had to move the highway further south. They had to also move the highway further east as well. They had to move the highway further east right there. Okay? That's because those molten pots were very hot. And those pots moved just like they do in Yellowstone, like they do at the other volcanoes around this country and around the world. Okay? That's what happens here in Imperial Valley. This whole area from the north side of the Salton Sea, just north of the Salton Sea, down here to the Mexican border, is called the Imperial Valley. They have earthquakes, anywhere from 75 to 150 earthquakes a day here in the Imperial Valley. Or from 75 to 100 to 400 earthquakes, 500 earthquakes a day here in the Imperial Valley, every day. Every day. Calipatria alone has anywhere from 75 to 150 earthquakes in Calipatria. All throughout the Imperial Valley together, we have close to 500 earthquakes a day, every day. Every day, without fail. What happens up here in Los Angeles? I've shown you earthquakes all day long today here in Los Angeles. Over 400 earthquakes a day here in Los Angeles. What are they showing? Almost nothing. Almost nothing. Basically, they show this earthquake here, Idlewild, California. 0.7 microquake. Right next to it is 1.1 tremor here in Idlewild. They're showing this one here in Redlands, 2.0 earthquake. Over here, just south of Corona, 1.5 tremor. Over here, Yorba Linda, where President Nixon was born, 1.0 tremor. Where are all the other earthquakes that they should be showing here? They're non-existent. That's because the USGS wants to say nothing happens here. Nothing happens here. Just like they're saying about Oregon and Washington, or nothing happens. Bullcrap. We show it every day we talk about it. Every day we talk about it, guys. It happens. Do we have any questions? Do we have any questions here? I'm happy to take any questions you might have. When it says it's always bouncing, you're right, it is. Watchdog here is with Tornado Nathan over in Mississippi. Nathan, welcome. We appreciate you. Nathan's also a friend of our program. Watchdog says Nathan showed him this channel. Thanks, Nathan. Appreciate it. He said to say hello to a dear friend, Ron. Thank you. Thank you, Watchdog. Appreciate it. Thank you, Nathan. You can see Nathan here on YouTube. He has his own weather channel here on YouTube. Okay? Tornado Nathan on YouTube. Hurricane Heather says, I know Tornado Nathan. You sure do, Heather. He's a friend of ours. Unreal. Yes, Watchdog, he says he's feeding a puppy he saved. I would love to have that puppy. He found a puppy that was maybe just weeks old, just barely surviving in the cold, almost frozen. Nathan had to give the puppy CPR to keep it alive. Now they're feeding it a milk Karo syrup mixture to get that puppy to gain weight and grow. Hopefully they'll save its life. I would so love to have that puppy myself. That would be fun. Would be a lot of fun. Any other questions here? Any other questions about earthquakes? Right now we have over 54 people watching still. YouTube is suppressing this channel. They don't want us to talk. They don't want us to talk here. They're trying to suppress it, telling people, oh, there's nobody seeing this channel. Bull crap. Bull crap. Alaska's earthquake on Saturday. Alaska's earthquake on Saturday. They showed us maybe 250, 300 people that watched the channel, watched our channel talk about the earthquake. The first thing we got in the morning. Guess what? By midnight Saturday night, we had almost 2,000 people that watched that channel. 2,000 people. That means YouTube suppressed this channel. YouTube suppresses this channel every day. Guys, if you want to watch this channel, please do it. Please subscribe to this channel. YouTube also keeps unsubscribing people here. Subscribe to this channel, and when you do so, there's a little bell icon right next to the subscription button. Click on that little bell icon. When you click on that bell icon, a drop-down menu of 3 items are going to pop up. Click on that item called ALL. That should get you notified when we come on the air, but be advised. YouTube does something else sneaky. They keep unsubscribing and they keep not notifying people when we come on the air. That's why I tell people we come on the air between 4 and 4:30 between 4 and 5 p.m. Eastern time every day. Between 4 and 5 p.m. almost every day. Occasionally it's a bit later because I'm still gathering information for our program. But I try to come on the air between 4 and 5 p.m. Eastern time every day. Today it was right before 4:30. I appreciate each one of you being here. Guys, please, I'm almost begging you, if you like this channel, help support this channel. Our car just gave up because the alternator died. We need to replace the alternator. It's going to cost between $100 and $400 to replace the alternator. You can go over to our PayPal locations here that's going across the bottom of your screen and give us or send us donations to our PayPal to keep the channel operating and to get our car back on the road. We'd greatly appreciate it. Thank you for that. Also, guys, you see our email address going across the screen. If you want to help support us, to tell us about our weaknesses, tell us about things you'd like to have on this channel, or just ideas that you'd like to see, email us, rltnsbdema@gmail.com. You also see our mailing address here, 504 Bethel Road, Box 401, Morganton, North Carolina. The zip code here is 28655. 28655. Send us a letter. Send us a card. We don't get cards and letters very often. About 2 weeks ago, we had a card from our buddy Laura and John from over in Oregon. We said we appreciate that. Hurricane Heather just gave us a $5 super chat. Heather, thank you so much for that. I'm giving you an EMA sticker on your super chat. I'm also giving you a thumbs up for that. Thank you very much. I don't know why when Renee gave us a $10 super chat earlier that we were not able to give her an EMA sticker on her super chat, but I'm doing that for Heather because it's allowing me to do it. God bless you, Heather. God bless you, Renee, for giving us super chats. We appreciate it so very much. Helps keep this channel on the air. I appreciate and love you all very much. I do. But folks, if you have it in your ability to send us money to help keep our car back on the road so we can go get groceries at the grocery store and other places, we'd appreciate it very much. We greatly appreciate it. My wife told me about it before I came on the air. Please remind everybody. So I just did. Again, you see our email address. You see our mailing address here. You can send us cards and letters. In the letter, you can tell us how you're preparing for emergencies and disasters in your area. Tell us about your family. We'd love to hear from you. Inside the letter, you can stick a donation, either check or even cash, inside that letter and mail it to us. Also, you can do the same thing on the card. If you want to send us a card, talk to us. Tell us about how you're doing. Talk to us and tell us how you're preparing for emergencies and disasters in your own life. We greatly appreciate it. Thank you for that. Inside that card letter, you can also stick donations and mail it to us. We greatly appreciate it, guys. Thank you so much for that. We appreciate each and every one of you being here. Thank you for being here. Now, guys, this is the Christmas season. I've told you about the Christmas season here before. I'm going to repeat myself again. This is a time of giving. This is a time of making sure those that you love know that they are loved. Don't take a second thought about telling someone you care about them. They might be down and out. They might need to hear your voice. They might need to hear you tell them how much you care about them, that they're valuable in your life. People are in that state right now this time of year. They need to hear that. They need to hear that every day. Don't ever let anyone go by throughout your life without telling them that you love them. Do that. Do that, pretty please. God said his one and greatest commandment is love one another as he has loved us. The greatest commandment is love. The greatest commandment is love. This is a season of love. This is a season of giving. When you think about Christmas, think about giving presents of preparedness presents. That way, when some disaster or some emergency comes along, those people you love and know get those presents of preparedness. That helps them and helps you also love them. That helps them prepare for whatever happens. This channel is all about preparedness. .0 over in Yukon Territory, Canada, northern Canada. That's another aftershock of the Alaskan earthquake on Saturday. Okay? Again, this is love. This is a time of love. Demon Catman says you can also join this emergency management channel for as little as $1.99 a month. Right below this channel in the program description, you can see a link that allows you to join this Emergency Management Associate channel as membership for as little as $1.99, $2.99, or $3.99 a month. I kept those amounts low so you can feel free to join it. I don't pressure anybody to join this channel. I don't pressure anybody to do anything. But I've kept the payments low so you can afford it. I know one channel that she charges $50 per person. I know that another channel charges as much as $50 a person as well. Several channels like that here on YouTube. I don't do that. I want people to join this channel so when we have a members only meeting, which we have sometimes infrequently, you can join this channel and feel good about it. When we come on the air, we talk just to you as members. We may do that this week. We may do this as early as Thursday or Friday morning this week. We love and appreciate you guys so much. May God bless you. May God be with you every day, 24/7. You can have God's Spirit to be with you. Pray. Pray and be humble. That way you have God's Spirit to be with you all the time. My dear friend, Demon Catman says, compassion is the key to a better world. I totally agree. Thanks for that, Demon Catman. Dean, you're awesome. You're awesome. Rich Quake over in Nova Scotia, Canada says he's been feeling a lot like Jacob Marley from Christmas Carol. I know that feeling. Been there, done that. Guys, I hope you have a good night and better tomorrow. If anything happens tonight or in the morning, we'll be back on the air just like we were this morning if something happens. As soon as the information becomes available, we'll come on the air and tell you about it. Other than that, sometime after 4 p.m. tomorrow evening, we'll be back on the air with another episode of Emergency Management Associates. Please join this channel. Please think about sending us a donation on our Venmo or on our PayPal. Our Venmo still doesn't work, but our PayPal does. May God bless you. May God be with you always. I love and appreciate each and every one of you guys. I really honestly do. I can't tell you that enough. You guys are my family. You guys are my family. Carol and I love you all very much. God be with you until we meet again. We'll see you on the other side. Good night, everybody. Much love.
Here at Emergency Management Associates, we're dedicated and true, bringing you the essential knowledge, helping you see things through. From disaster preparedness to navigating recovery's embrace, we're here to guide you in every unpredictable time and place. We break down the complex, make it easy to grasp and absorb, sharing strategies for safety, the vital lessons you can't afford to hoard. So thank you for watching, and thank you so much for your sub. You're a key part of our growing family, a member of our knowledge club. With every like, every share, and every comment you send our way, our critical message spreads further, helping more people every single day. Together we're stronger and more prepared. That's the truth we all abide. You help us build resilience with nowhere for uncertainty to hide. Your engagement truly inspires us. Your feedback acts as a guiding light, helping us continually grow and making our channel's future bright. We're always learning, always striving to be better, bring you the most up-to-date information, no matter the weather. Emergency Management Associates is here for you now and forever, it's true. Keep watching, keep learning,